The modern aircraft cockpit is a marvel of engineering, a far cry from its humble beginnings. Early cockpits were Spartan affairs, dominated by a bewildering array of dials, gauges, and levers. These instruments, known as steam gauges, provided pilots with essential information about the aircraft's engine performance, altitude, speed, and heading. As aviation technology progressed, so too did the cockpit. The advent of digital displays revolutionized the way pilots interacted with their aircraft, ushering in an era of unprecedented situational awareness and flight control. This evolution from steam gauges to digital displays marks a significant turning point in aviation history. It represents a shift from primarily analog systems to sophisticated digital interfaces, enhancing flight safety and efficiency. This essay delves into the fascinating journey of cockpit evolution, exploring the challenges of early instruments, the benefits of digital displays, and the exciting possibilities that lie ahead with technologies like augmented reality, virtual reality, and artificial intelligence. Early aircraft cockpits were dominated by steam gauges, mechanical instruments that relied on tubes, gears, and needles to relay flight information. These gauges were simple in design but effective in their purpose. For instance, the altimeter, a crucial instrument for determining altitude, used a sealed capsule containing an aneroid barometer. As the aircraft ascended or descended, changes in air pressure caused the capsule to expand or contract, moving a mechanical linkage that rotated the needle on the dial to indicate the corresponding altitude. While these analog instruments were reliable for their time, they had limitations. Steam gauges were susceptible to mechanical wear and tear, potentially affecting their accuracy. Additionally, interpreting multiple gauges simultaneously could be challenging, increasing pilot workload, especially during critical phases of flight. The reliance on numerous individual instruments for different parameters made it difficult for pilots to form a comprehensive picture of the aircraft's overall state. The transition to digital displays addressed these limitations, paving the way for more intuitive and integrated cockpit systems. The introduction of digital displays in cockpits marked a paradigm shift in aviation technology. Unlike their analog counterparts, digital displays offered a more intuitive and versatile way to present flight information. Electronic Flight Instrument Systems, FIS, emerged, utilizing digital screens to display flight data in a clear, concise, and customizable format. This advancement significantly reduced pilot workload and improved situational awareness. Digital displays offered several advantages over traditional steam gauges. Firstly, they could present a wider range of information in a more organized and easily digestible format. Pilots could customize the information displayed on the screens, prioritizing critical data based on the phase of flight. Secondly, digital displays were more reliable and less prone to mechanical failures. They could also be integrated with other aircraft systems, allowing for the display of navigation data, weather information, and system warnings on a single screen. Section 4. The advent of EFIS and glass cockpits. The development of EFIS led to the emergence of glass cockpits, where traditional steam gauges were replaced with digital displays. Glass cockpits further enhanced situational awareness by presenting a holistic view of flight parameters, navigation data, and system status on large, high-resolution screens. These displays could be easily configured to suit the pilot's preferences and the specific mission requirements. One of the most significant advantages of glass cockpits was the introduction of the primary flight display, or PFD, and the multi-function display, or MFD. The PFD typically displayed critical flight information such as altitude, airspeed, heading, vertical speed, and attitude, presented in a clear and intuitive format. The MFD, on the other hand, could be configured to display navigation maps, weather radar, system schematics, and other relevant data. This division of information further reduced pilot workload and allowed for better decision-making during flight. Section 5. The future cockpit: AR, VR, and AI. Looking towards the future, cockpit technology continues to evolve at a rapid pace. Emerging technologies like augmented reality, virtual reality, and artificial intelligence are poised to revolutionize the way pilots interact with their aircraft and the surrounding airspace. AR, could overlay critical flight data onto the pilot's real-world view, enhancing situational awareness in low-visibility conditions or during complex maneuvers. VR could be used for immersive pilot training, simulating various flight scenarios and emergencies in a safe and controlled environment. AI has the potential to transform the cockpit into a highly intelligent and adaptive environment. AI algorithms can analyze vast amounts of flight data, providing pilots with real-time insights, predicting potential issues, and suggesting optimal courses of action. Imagine a cockpit where AI acts as a co-pilot, assisting with flight planning, fuel management, and even controlling certain aspects of the flight, freeing up the human pilot to focus on strategic decision-making and overall mission management. Section 6. Pilots and the human factor in the digital age. While the evolution of cockpit technology offers numerous advantages, it also necessitates a shift in pilot training and adaptation. Pilots need to be proficient not only in the traditional aspects of flying, but also in the operation and management of sophisticated digital systems. Understanding the intricacies of digital displays, flight management systems, and autopilot functions becomes paramount. Moreover, pilots need to develop a deep understanding of the limitations of automation and be prepared to take over manual control in the event of system failures. Despite the increasing sophistication of cockpit automation, the human pilot remains an indispensable element of the equation. Human judgment, decision-making, and airmanship are crucial in handling unexpected situations, dealing with emergencies, and ensuring the safe operation of aircraft. As technology continues to evolve, the role of the pilot will likely transition from a primarily hands-on operator to a systems manager and decision-maker. Striking a balance between automation and human control, while fostering a deep understanding of the capabilities and limitations of both, will be key to ensuring continued safety and efficiency in the digital age of aviation.